All right, let's talk about one of the coolest ideas in all of science fiction, something we've all seen in shows like Star Trek, the warp drive. But we're not digging into a Hollywood script today. Nope, we're going straight to the source, a totally groundbreaking paper from 1994, written by a physicist named Miguel Alcubierre. He basically asked, could faster-than-light travel actually be a thing within the laws of physics as we know them? So that's the big question, isn't it? Is the whole idea of zipping between stars faster than a beam of light just going to stay on our TV screens forever? Or could it one day become reality? Well, to even begin to answer that, we've got to talk about the single biggest roadblock for anyone who wants to travel the stars. And that roadblock, that ultimate barrier, is what physicists call the cosmic speed limit. And it's not like the speed limit on the highway. It's not a suggestion. It is a fundamental, unbreakable rule of our universe that seems to make any dream of a galactic civilization pure fantasy. So where does this rule come from? It comes straight from Einstein and his theory of general relativity. And the theory is pretty clear. Nothing with mass can ever reach the speed of light, let alone go faster. But look closely at that slide. See that word in italics? Locally? It means that within any little patch of space, nothing can beat a photon in a race. Now that word is everything. It's a restriction for sure, but it might just be a clue. So how can one word change the game? Well, that word, locally, opens up this fascinating potential loophole. A loophole that was completely blown wide open in a bombshell paper that suggested a totally radical new way to think about getting from point A to point B. And this is it, the warp drive, hyper-fast travel within general relativity. This is the paper. When Miguel Alcubierre published this in 1994, he wasn't trying to break the laws of physics, oh no. He was trying to bend them. He wanted to see if Einstein's own theories could be used to find a cosmic shortcut. And here is the jaw-dropping conclusion, pulled right from the abstract of the paper. Alcubierre says it's possible to actually modify space-time itself, so a ship can travel at, and I'm quoting here, an arbitrarily large speed. Think about that. The trick isn't to go faster through space, but to change the fabric of space itself. So how on earth could that even work? I mean, it sounds completely wild, but the concept is actually pretty elegant. You have to stop thinking about a rocket blasting through space and start thinking more like a surfer riding a wave. Only this wave is made of space-time itself. And this is the absolute core of the idea. The spaceship, it doesn't really move, not in the way we think of movement. It just sits there, chilling inside a little bubble of perfectly flat, normal space. The genius part is you're not moving the ship through space, you're moving the bubble of space. And the ship is just along for the ride. Now, this is figure 1 right from Alcubierre's paper, and it shows you exactly what's happening. You can see how the space-time in front of the ship gets all squeezed and contracted. It's literally pulling your destination closer. And at the same time, the space behind you is expanded, pushing where you started further away. So we can boil this whole trip down to 4 steps. First, you have to create this warp bubble to protect your ship. Then, you squeeze the space in front of you. Third, you stretch out the space behind you. And fourth, you just ride that distortion, that wave in space-time all the way to your destination. And because it's space itself that's moving, you get there faster than light could have. And this leads to maybe the most incredible part of the whole thing. Since the ship is technically just sitting still inside its bubble, the crew wouldn't feel any of those weird time-bending effects, no time dilation. So a trip that feels like a week to you is also a week for everyone you left back on Earth. It completely solves that whole twin paradox problem. Okay, so faster than light travel, no freaky time side effects? This is starting to sound absolutely perfect. Maybe a little too perfect. And yeah, as you probably guessed, there's a catch. A massive, universe-sized catch. The math works, but the ingredients you need, well, that's where it gets complicated. Alcubierre knew this, and he pointed it out right there in his paper. See, to bend space-time in this extreme way, you can't just use regular old matter and energy. You need something else. Something different. And the paper shows the math to prove it. Now, you don't have to be a physicist to get the problem here. It all comes down to that one little symbol, that minus sign. That little dash means that the energy you need to power this thing has to be negative. In our normal world, energy is always positive. This is like needing a fuel that has less than 0 energy. It just breaks all the classical rules. So this requirement for negative energy leads us to this theoretical stuff called exotic matter. And let me tell you, exotic doesn't even begin to cover it. This isn't just something that's hard to find, it's something that, as far as we know, doesn't exist. We're talking about theoretical material that has negative mass or negative energy. It would basically have anti-gravity. It is the single biggest hurdle to making this a reality. So where does all this leave us? Is the Alcubierre drive just a beautiful piece of math that's doomed to stay on paper forever because of this one impossible ingredient? Or is there still a tiny glimmer of hope? You can really see the paradox laid out right here. On one side, you have this incredible dream. Zipping across the galaxy faster than light, the crew feels no g-forces, and nobody ages differently. It's perfect. But on the other side, you have the impossible shopping list, exotic matter, probably in amounts that are just unimaginable. And, oh yeah, we have absolutely no idea how to make it. But Alcubierre himself offers one last, tantalizing clue in his paper. He points out that while our normal, everyday physics says no way to negative energy, the super weird world of quantum mechanics might not be so strict. He notes that quantum field theory does actually allow for tiny, fleeting pockets of negative energy to exist. We've even seen it in things like the Casimir effect. It's a tiny crack in a really solid wall, but it's not sealed shut. And that's really where we are today. The Alcubierre drive is a concept that's perfectly balanced on a knife's edge between what we know is possible and what seems like a total mystery. It's this elegant solution in search of an impossible material. And that leaves us with one final huge question to think about. If we could ever figure this out, if this were actually possible, what would that really mean for us, for the future of humanity?